Okay, our final application for today, assuming I don't add more videos later, is regarding payment streams. Now, we did this already in Unit 1, and you may have even been tested on it, though it depends on the term and how much time we've got in the term, because it's been varying a bit lately with everything. But the same concepts here. We just are going to apply compound interest to the questions instead. So what was the concept? We are replacing a set of payments with a single other payment, but we can only add or subtract payments if we bring them all to the same date. We call it a focal date. So remember, $1,000 plus $2,000 plus $3,000 on different days is not worth the same as just $6,000. You know, because sure, I'd rather take $6,000 today. That's actually worth more than those three payments put together, because I could be earning interest on it all the way along. Now, how do we tackle this problem? It's just three separate problems. It's just so what is the problem? Let's read it. Payments of $1,000, $2,000, and $3,000 were to be paid 2 years, 4.5 years, and 7 years from now, time 0. What equivalent payment could be made 5 years from now if money can earn 5% compounded monthly? So same interest rate for all of them, which is great. If you're using the calculator, you put those in once and you're done for that, the interest rates. So, like I say, the idea is to treat this like three separate problems and then just add up at the end. So I have a contract where I owe someone $1,000 2 years from now. I can't afford to pay them at that time. I instead pay them 5 years from now. That means I paid them 3 years later, so I want to add 3 years of interest to the $1,000 I owed. So I'm basically borrowing $1,000 for 3 years. Here, I'm borrowing $2,000 just for half of a year. These are not to scale, I just want to space them out. So $2,000 plus just 6 months of interest, or half of a year. And then this $3,000, we're going to pay that ahead of time. So we find instead what lesser amount should we pay early, or how much we would put that money in a bank account or something like that, so that 2 years later that's worth $3,000 and can pay the person. Or we're paying them an amount early, given that they could be earning that interest rate. So an equivalent amount will be less than $3,000 for that payment. And then once we have those three, we can add them all up. So that's what we're looking to do. We're going to take these two amounts forward and this one backwards. Technically, because it's compound interest, you could move things around any way you want. But I think it's still easiest to think of the one focal date as this is when we're making the payment. Let's just take all the values forward or backwards to that date and add it up. Instead of doing, you could take the $1,000 forward to here and then add $2,000 and take that whole amount forward again, and you'll get the same answer if you do it right. But let's do it all to the one focal date. So that means these ones are in the past, so PV1 is $1,000. I guess the signs don't matter too much. Shall we do them all positive anyways, and then we'll see what, because we're kind of borrowing the money, and then we'll see what we pay at the end. But you can do them all negative. That is what I've been doing pretty much so far. This guy will be PV2. And this guy in the future will be FV3. And now we're going to bring them all to here. So bring this one forward to find FV2. Bring this one forward to find FV1. And bring this one backwards to find PV3. And then find the total for all three. Just adding them up once we've calculated them. Okay. We need to find n for each of these cases. So remember, so this is this $1,000 is due 2 years from now. We're paying it 5 years from now. So 5 minus 2, this is 3 years. So N1 is going to be 3 years times 12 compoundings per year. That's going to be 36 months. It's compounding every month. So we can just count months, but either way, 36 compounding periods. This is 0.5 years times 12. That's going to be an N. So here, this N2 is going to be equal to 6. It's just 6 months, half of a year. And this, 7 minus 5 equals 2 years times 12. N3 is going to be equal to 24. 2 years, 24 months. We could have tackled each one of those separately and just solved first. That's fine too. But, okay, we have N's, we have PV's, we have everything. Let's start calculating. So I'm not going to restate the interest rate and compounding. That's right here. But I guess just to clarify again, so PV1 equals 1,000, N1 equals 36, compute FV1, and I would still store these numbers in your calculator with the memory function so you don't have to retype them, but in this case I get negative 1161.472, so carry at least to the third decimal place for accuracy. Preferably just store the number in your calculator and then you don't have to retype it at all. Okay, PV2 equals $2,000. N2 is only equal to 6 months, 6 compounding periods. Compute FV2, we get, it's not too much, it's not too much interest added, it's only $50 about, so negative $2,050, 0.524. And now the third one. So in the third one, FV3 is equal to $3,000. N3 is equal to 24. We're going to compute PV3. So like I say, this third one we're bringing back. So yes, we owed $1,000. 3 years later, we'll instead pay $1,161. We owed $2,000. 6 months later, half a year later, we'll pay $2,050. We owe $3,000 at the end, but we're going to pay it early, so instead we will pay $2,715.076. So a little bit less than $3,000. And now we can just add them up. Total. So the total, we're just adding all three, we get 5927.07. It's a lot of number crunching, but actually you only have to enter some of the pieces of information once. And of course, well, yeah, remember, does it say payments? It does say payments, so just to re-emphasize, PMT is equal to 0. That's still, for this whole unit, don't think of that payment key as these sort of payments, because they're not on a regular schedule. So the math, we don't have a simple formula that works when the payments are staggered at weird intervals of time. So, actually I guess they kind of are on a regular schedule, but still we're trying to convert it. They're every 2.5 years, but don't worry about that. We're still trying to figure out one single payment on this focal date 5 years from now to settle this whole account. And so it ended up being just slightly less than $6,000. You knew it was going to be somewhere around $6,000, but it could have been a little bit more or a little bit less. It depends where it fell in the timeline, and we had these three payments, $1,000, $2,000, and $3,000. Well, if the $3,000 one had come first, then that would have built up more interest early, and this payment would have actually been probably more than 6,000 by the end because of the extra interest owing. So, but at least it gives us sort of a ballpark range. So it's going to be somewhere more or less than that by a bit. But really, we've just replaced these 3 payments owing by their 3 separate calculations and totaled it up. Once we brought all the values forwards or backwards to this date, then we could add it up. It is handy to do a timeline for this purpose. I generally won't worry about requiring it for marks in the test, but it can never. It doesn't hurt. It doesn't hurt to show and to have an idea how your thoughts are organized, or just so that I have an idea for part marks in case you don't get this final answer. But otherwise, you'll see, like I say, on the practice sheet, I have 3 rows of boxes, so you'll basically be filling in same interest rate for each time, but different, PVs and N and FVs that you'll be computing, and so you can find those numbers, and then just final amount is to total the 3. Yeah, so just this and this and this. I know I dropped the negative sign at that point. It doesn't, because again, it's really, this is the dollar amount that would replace those 3 payments. Negative is just because the calculator needed to handle it, just to balance an equation. So, okay, thanks, good luck with all that. Next week, we will go further into then figuring out calculating instead a bunch of other applications where we'll calculate the interest rate, or we'll calculate N, and see how that works out. See and some of the interesting things you can do with that, and some of the complications that come up. When you calculate N, we usually do want to convert that back into a number of years, not listing, oh, I want to get this, I'll pay back this loan in 42 compounding periods. It's like, yeah, but how many years is that? So yes, we'll have to we'll take what we know and we'll turn it around a little bit. But fortunately, if you're practicing with the calculator, a lot of it shouldn't be too bad, as once you identify these variables, you're just going to compute for something else, compute for IY or compute for N. You just might have to do something extra with it afterwards, possibly. Thanks. Good luck studying on this.